Hi, I'm Michael Elkington. I'm going to talk you through my work on understanding the lamination process. Hand layup of prepreg is still quite heavily used in the industry. Some of the good parts about it, it's really good for complex parts. It's got particularly short lead times, and the setup costs are low, both for a product and for a whole factory. Some of the negative sides, it's particularly labour intensive, so it tends to be quite slow and quite expensive. Again, because you've got humans involved, it can be quite variable. And if you're looking to scale up the process, there is a possible shortage of laminators. The process hasn't changed very much in the last 3 decades. It's been to a clean room, it looks very much the same. So there is the scope for optimization, something which has been applied to lots of other areas of composites, but not hand layup. So the knowledge gap, really, in lamination, we know take a flat sheet of prepreg, try and put it over a doubly curved mold, you're going to need in-plane deformation. And there's programs. Here we use virtual fabric placement, which is a Bristol software, but there's various programs that will do it, which can take a flat sheet and predict what deformation will be needed to fit over a 3D shape. The gap in the knowledge is exactly how that deformation is achieved by a real laminator. And that's where we're looking to build the knowledge. This hasn't really been approached before in engineering. There's nothing in the literature looking at how these processes are done. And the methods we use are not very common in engineering. But in the fields of experimental psychology and psychology, these things are a lot more frequent. So we've borrowed a lot of techniques from there. So it's a fairly simple process. We record operators at work, so some laminators. And then we watch the footage again, and then we can analyze it frame by frame manually. And we were recording the frequency and the location of where they used different techniques to try and understand what they were doing and where they were doing it. So the tasks were 19 layup trials we developed, covering different shapes, different severities of angle, which we tried to build up a collection which represented some real parts. The subjects were 6 laminators, 2 novices, 2 intermediates, and then 2 professionals. We've been doing it for years. And they each did each one 3 times and recorded it, and we've been analysing the footage. And we've got quite a large number of conclusions. This little talk through, I'm just going to take you through a few things we've been getting to give you a flavour of what we do. We found there were 7 techniques, and you can see them all here, which represent almost everything that laminators were doing. In this context, you won't understand exactly what they all are, and they're covered in some papers that we put out. So we kept each action that a laminator does can be classified into one of these 7 areas. And the most important thing, once we'd found techniques, was to find out where they were being used. So what is each technique for? So there were certain techniques, such as you can see here, which is called one-handed guiding. It looks really simple, and it's probably something you'd use to align sellotape or a similar material. But what was interesting was that the novices, the professionals, the intermediates, everybody all used this technique every time you had to align the prepreg to the edge of a part. So you can see here, this is prepreg which is stuck in this corner. And this area here is free, it's not stuck to the tool. So one hand holds the prepreg at the corner where it's stuck already. The other hand helps to align it. Simple conclusion, but it's interesting to see that it's used everywhere. It becomes a bit more complex when you start introducing some of the 3D shapes, some of the deformation that you've required. And to give you an interesting idea of what you can see from doing this, I've compared 2 ways of laying up exactly the same part. So you have A on the left here, B on the right. And you can see it's the same part, it's a flat section with a recess in one corner. And part A, designated, is started from the front surface and part B from the back. And these are some predictions of the deformation you get, and you can see they're very different. But if we concentrate on this area here that's highlighted in red, on both parts it's the same area of the tool. The deformation's around 20 degrees shear. So on a basic terms they look more or less the same, and you expect them to pose a similar sort of problem. What we found was that if you compare task A and task B, how they were made, they're completely different. So here we have task A, that was the one that's on the left previously, and this goes in a clockwise direction. you can see that before they reach the corner, there's folds in the fabric and it needs some manipulation. And what we found was that all the laminators, on average about 4 times every time they lay down a ply, use this technique. So they hold this corner where the red dot is, that's being secured to stop it sliding across the tool. And the other hand is applying tensions in the direction of that arrow. And this directly applied tension shears the material. You can see here the green schematic shows how it works. And this technique was used exclusively, so 4 times every ply. Now, if you move to task B, again, we said the area to initially, it looks very similar. They didn't use that technique at all. They used something completely different, something called tool interaction shearing. They used this 12 times on average, so it's pretty frequent use. So here, the ply is starting from the top surface, and they're using 2 fingers to push it into the recess. And by doing that, they're actually generating tension in the fabric, creating the shear. And you can see here the schematic again, the shear is changing. Sorry, the shear is being created. So we've looked at a lot more than these 2 areas. We looked at lots of different features and tried to understand why there are differences in techniques. And this is covered in some of the literature we've put out. At the moment, so we're at a stage now where we can take a tool and we can model it using virtual fabric placement to get an idea of the deformation. And then we can look at characteristics such as the shear angle, the direction of the layup, so where did it start, where is it going to. The topology is looking at negative, positive Gaussian curvature, that kind of thing, and the direction of the fibers. And from there, we can get to a point where we can predict what techniques would likely be used, so what techniques would be applicable to that region. So the conclusions of the work so far, we've identified these 7 techniques which are key to lamination. And we've shown that there are clear links between techniques and specific areas. And in those links, you have to consider more than the shear area, so the shear angle. But the angle of the shear that you created is not the only thing you have to worry about. There's various other features. So applying this technique, this knowledge, on the training side, we now have an understanding of, we can look at any part, look at the features on it and say what technique is going to be used. That gives you a real head start if you're trying to train someone. In the automation field, the list of 7 techniques, for a start, gives you a specification, if you will, for any sort of automated process which is looking to manipulate prepreg. So we've used the problem-solving skills of the human being, of the laminators, to create a series of techniques which would need to be replicated in an automated system. And also, we're looking to evolve the process. As I said at the start, it's still a competitive process. It still works and it's still viable for making a lot of parts. But it hasn't changed. So we're looking, now we understand a bit more about what's going on, it gives us a foothold, if you will, to move on and to try and evolve the process, change some things, maybe get a bit more productivity out of it. Directly looking at some of the work which is going on at Bristol now off the back of this project. We have someone looking at improved layup tools. So looking at how you can create tools to enhance these techniques. We're also looking into providing detailed layup instructions, because if we now know exactly what techniques would be used, maybe you can start giving more advanced, more detailed instructions, like you would expect for, say, flat pack furniture or something like that, that would allow anybody anywhere in the world to pick up a part and be able to make it to the same quality, the same specification that we think they will. As part of that, there's existing systems which can project information about a ply during layup, and we're looking at maybe integrating some of the knowledge that we have into making these systems a bit more advanced, giving the laminators a bit more information. And the work I'm doing now is looking at the pre-shearing of the plies. One of the key conclusions from the work was that laminating itself is a very complex process. There's a lot of actions, a lot of repeated actions, sometimes in difficult places, and we wonder whether it's possible to change that. So I'll talk you through briefly this work. As we said, there's a large number of applications of actions and techniques, which is trying to create the shear on the tool, which is not often the easiest way of doing it. So we created what we've called pre-shearing. This chart shows you how it works. So you start with a model of the deformation that you want, and this will be sort of approved by structures and stress analysis. And then you can transfer that deformation to the original ply, so the flat ply, you show which bits are going to be deformed. And then you can create that deformation off the tool. Here I've used two specially adapted, these are aluminium bars, and whatever tool you might have, you can create the shear easily. So when you come to apply it to the tool, it fits in the tool nicely, the shear's already been created, and it creates some pretty radical changes to the times involved. So in terms of the time spent on the tool laying up, we saw huge reductions, and then a less but still significant reduction in the overall time. A big decrease in defects, especially looking at inexperienced laminators. And the main sort of important thing was that we had novice laminators who really struggled with doing it in the traditional manner, starting with a flat ply, saying that doing it this way in the two stages was easy, and the times and that thing, they agree with those comments, and we're hoping to put this work out very soon. Thank you for listening to my project. Any questions, feel free to email me at michael.elkington@bristol.ac.uk.